What if the universe had sent a question in the shape of stone? A fragment older than the sun, tumbling silently into the realm of our star. It was called Oumuamua, a name that means scout in Hawaiian. The first known interstellar object ever seen passing through the solar system. To astronomers, it was neither wholly comet nor wholly asteroid. It left no clear trail of ice, no bright coma of gas, yet its motion was not entirely bound by gravity alone. It drifted like a scar across the darkness, a shard of somewhere else, a messenger carrying no words but heavy with implication. For billions of years, the solar system had been a closed theater. Every planet, every moon, every comet had been born from the same ancient cloud. Then suddenly something alien appeared. Not of this family. Not of this sun. Telescopes strained to capture it as it sped past, already leaving us behind. The data showed contradictions. Its shape, elongated beyond any asteroid known. Its path bent by something unseen. Its presence, fleeting yet unforgettable. Some called it a cosmic accident, a random traveler ejected from another star's nursery. Others wondered if it was something more, a relic, a signal, a fragment designed to stir the silence of interstellar space. What remains certain is only this: Oumuamua came unannounced. It asked no permission. It carried no clear message. Yet everything humanity knows about it is haunted by the vastness of what we do not. The mystery endures, as though the cosmos had whispered and left us to wonder if we had truly been spoken to. In the autumn of 2017, at the summit of Haleakala in Hawaii, the night sky was under watch. The Pan-STARRS 1 telescope, a sentinel of glass and mirrors, swept its gaze across the heavens. It was designed not for beauty, but for vigilance, to map the sky, to trace the faint signatures of objects that wander near Earth, and to guard against the silent threat of asteroids that move unseen. That night, astronomer Robert Varick studied the stream of data. Among the countless points of light, one betrayed itself. It was faint, moving quickly, and unlike the usual suspects cataloged in the endless inventory of the sky. At first, it seemed to be a comet, a frozen body releasing gas as it approached the sun. But where was its coma, its trailing plume, the telltale breath of sublimating ice? There was no soft halo, no shimmering tail. The light was bare, stark, unadorned. Warwick looked closer. The motion was wrong. This was not the familiar dance of an asteroid, circling in the gravity well of the sun. When he compared multiple nights of data, the trajectory drew itself into something stranger. Not an ellipse, not even the stretched oval of a long-period comet, but a curve that refused to close. It was hyperbolic, a path of exile. This object had not been born in the cradle of our solar system. It had entered from elsewhere and was already on its way out. For centuries, humanity had looked at the stars and imagined visitors. Comets had once been omens of disaster. Asteroids had been seen as wandering stones, children of chaos. But never before had science confirmed that something truly interstellar had crossed into the realm of our sun. The discovery was unprecedented. Calculations showed its velocity was far greater than any bound object could sustain. As it passed near the sun, it had accelerated beyond the grasp of gravity, moving at nearly 87 kilometers per second. Nothing born of this solar system could travel so. This was the unmistakable fingerprint of an origin among the stars. The announcement spread quickly through the scientific community. An interstellar object, the first ever observed. For decades, astronomers had theorized such wanderers must exist. Stars form in clusters, their newborn systems crowded with debris. Gravity flings much of it outward, scattering countless fragments into the void. The galaxy, they believed, must be full of these interstellar refugees, drifting between stars like seeds in an eternal wind. Yet none had ever been seen until now. The object was small, perhaps no more than a few hundred meters in length. Its surface reflected light in strange, variable ways, suggesting it was elongated unlike any asteroid cataloged. Some models painted it as a cigar-shaped shard. Others suggested a flat, disc-like body, tumbling as it moved. Even in its faintness, it defied easy description. Confusion mounted. If it was a comet, why no outgassing? If it was an asteroid, why such a bizarre trajectory? Every detail added weight to its mystery. At Haleakala, the Hawaiian name chosen for it was poetic in itself, Oumuamua. It meant scout or messenger, a word that carried both the simplicity of a label and the unease of interpretation. For it was not merely an object. It was the first to cross the solar system and confirm that the great void between stars is not empty, but alive with wanderers. The discovery forced reflection. Astronomy had long been a discipline of patience, measuring orbits that repeat over centuries, predicting the steady movements of planets and comets. Oumuamua was different. It had appeared suddenly, and already it was leaving. There would be no second chance. Every observation had to be made in haste. Every telescope pointed quickly before it vanished into the deep. The urgency electrified observatories around the world. The European Southern Observatory in Chile, the Hubble Space Telescope, and others joined the chase. Spectral data hinted at a dark, reddish surface, weathered by cosmic rays over millions of years. This was no young fragment. It had likely wandered the galaxy for eons, until chance brought it across our path. Yet even as the data accumulated, certainty remained elusive. Its brightness fluctuated as it tumbled by a factor of 10, suggesting an extreme shape. No asteroid in the solar system behaved quite like this. Some astronomers whispered comparisons to artificial constructs, not because evidence demanded it, but because imagination could not resist. If humanity had sent probes across the stars, would they not look like fragments of metal, slender and durable, tumbling in silence? Still, the sober voice of science urged caution. Unusual did not mean unnatural. Nature was vast and inventive. This was likely a shard of rock or ice, expelled from a distant system, wandering until it brushed against the light of our sun. And yet the questions persisted, for every explanation left shadows. In the days that followed, papers appeared on Archive, the digital archive of astronomy. Dozens of theories attempted to grasp what Oumuamua might be. A nitrogen iceberg, the fragment of a shattered Pluto-like world from another star. A hydrogen iceberg, sublimating too subtly to leave a visible tail. Or a dusty conglomerate held together loosely, a kind of cosmic puffball, fragile and strange. Each theory stretched the boundaries of what was known, but none silenced the unease. In historical context, this discovery was seismic. For centuries, astronomers had sought to understand the solar system as a closed system, mapping its boundaries. Then, in a single moment, a door opened. Oumuamua proved that the solar system is not isolated. It is part of a wider traffic of matter, an exchange between stars that occurs across unimaginable timescales. To glimpse one fragment was to glimpse a truth about the galaxy itself, and still, time was the enemy. Within weeks of its detection, Oumuamua was already too faint for detailed study. Its image shrank into the noise of the sky, leaving behind only the measurements hastily gathered. The messenger had arrived, revealed itself, and departed before humanity could ask its questions properly. What lingered was astonishment. In 2017, for the first time, humanity saw beyond the parochial borders of its own star system, not by looking outward at distant galaxies, but by receiving a visitor that had crossed the gulf. It was as though the cosmos had reached out with a single finger, brushing against the edge of human awareness. The discovery phase was brief, but it reshaped astronomy. Theoretical possibilities became undeniable fact. Interstellar objects are real, and they will come again. Perhaps one day they will be common in our skies, cataloged and studied as part of the cosmic environment. But Oumuamua was the first. and in being first, it carried with it an aura of myth. Even now, scientists debate its nature, and philosophers ponder its meaning. Was it a random shard, ejected by chance from the chaos of another system? Or was it something more deliberate? A whisper in the dark, a signal not of language, but of presence? Whatever the answer, the night of October 2017 marked a threshold. On that night, humanity learned that the stars do not keep their secrets to themselves. They send fragments, messengers, scouts. And in the silence of interstellar space, one such messenger brushed past us, leaving wonder in its wake. When Oumuamua's path was first traced, the revelation shook astronomy to its core. Its orbit was not closed, not bound to the gravity of the sun. Unlike the planets, unlike the asteroids, unlike the comets that sweep back after centuries or millennia, this body would never return. It had come once, and once only. Its path was hyperbolic, the mathematical curve of escape, and its velocity carried it beyond the reach of the solar system forever. For astronomers accustomed to orbits that repeat, the idea of a visitor that appears and vanishes with no return was astonishing. Humanity had peered at the stars for centuries, but the night sky had always felt like a familiar stage. Every comet, every asteroid belonged to the same celestial family, circling the same gravitational center. Oumuamua was the exception. It was a stranger that had slipped through the gates, crossing the solar system in silence, never to be seen again. Yet it was not the trajectory alone that unsettled science. The data told of something stranger still. As it rounded the sun and began its outward journey, Oumuamua accelerated in a way gravity could not explain. Comets, when heated, release jets of gas and dust that act like natural thrusters, giving them a gentle push. But telescopes revealed no such outgassing here. There was no tail, no coma, no faint cloud of material trailing behind. The acceleration was real, but the cause was hidden. NASA scientists calculated that the push was tiny, yet undeniable. Just enough to alter its speed by a fraction, enough to curve its trajectory away from what Newton's laws alone would predict. For a comet, this would have been natural. For an inert rock, impossible. Oumuamua seemed to exist in the space between categories, obeying neither asteroid stillness nor comet's breath. Its shape only deepened the puzzle. From its shifting brightness, scientists inferred that it must be elongated, reflecting light differently as it tumbled. At first, the models suggested a cigar-like shard, perhaps 10 times longer than it was wide. Such proportions were unlike anything seen in the solar system, where asteroids and comets typically resembled rough potatoes or irregular blocks. But as the data improved, other models emerged. Perhaps it was not a cigar, but a pancake, thin and wide, spinning like a coin cast into the dark. Either way, the proportions defied the familiar. Even its spin resisted easy explanation. Oumuamua rotated in a tumbling motion, not a steady spin about a single axis. This chaotic rotation suggested a violent past, perhaps a collision or an ejection so violent that it left the fragment spinning without balance. Astronomers had seen tumbling asteroids before, but never one like this. Never one moving so fast, never one so alien in origin. In the textbooks of astronomy, there had been no place for such a thing. Asteroids were local, bound, predictable. Comets were icy with their bright tails and their periodic returns. Oumuamua was neither. It was a paradox given form, slipping between categories, haunting the boundaries of definition. The scientific community wrestled with these contradictions. Some argued it must be a comet, its outgassing too subtle or too unusual to detect. Perhaps it released hydrogen, invisible to telescopes, or dust too fine to scatter light in the familiar way. Others leaned toward an asteroid, a fragment of some distant world, its acceleration explained by forces still hidden from view. Every theory tried to tame the strangeness, to press it into a known category, but the object resisted. In peer-reviewed journals and archive preprints, the debate unfolded. Papers proposed exotic compositions, a nitrogen iceberg, chipped from the frozen surface of a Pluto-like planet in another star system. Such a body could slowly sublimate, releasing gases too faint to form a visible coma, yet strong enough to produce the observed acceleration. Others imagined a hydrogen iceberg, rare and delicate, eroded by cosmic rays during its eons of travel. Such an object would vanish almost invisibly as it warmed near the sun, but each theory stretched credulity. A nitrogen iceberg required the existence of countless Pluto-like worlds scattered through the galaxy, ejecting fragments in great numbers. A hydrogen iceberg would have been fragile, unlikely to survive the immense journey across interstellar space. The possibilities expanded, but none fit perfectly, and so the whispers began. If natural explanations strained under the weight of improbability, could it be artificial? Some scientists entertained the speculation. If a distant civilization had ever sent probes between the stars, might they not resemble this? A thin, tumbling shard, reflecting light in odd rhythms, propelled by some force beyond ordinary gravity? Perhaps a solar sail, a relic of technology, its acceleration driven by the faint pressure of starlight. Harvard astronomer Avi Loeb argued for such a possibility, sparking controversy and headlines across the world. The majority of astronomers urged caution, preferring natural explanations, but the seed of wonder had already been planted. What gave this speculation such power was not evidence of technology, but the absence of certainty. Science thrives on categories, on patterns that repeat. Oumuamua refused to be categorized. It was unique, singular, unlike anything observed before or since. In that refusal, it provoked both awe and unease. For astronomers, the shock was not simply in the data, but in the implications. If Oumuamua was natural, then the galaxy is stranger and more inventive than models had predicted. If it was artificial, then humanity had brushed against the work of intelligence older and farther than itself. Either way, the event marked a turning point. The familiar sky had revealed itself as less familiar than imagined. As the object tumbled outward, slipping beyond the range of telescopes, the mystery deepened rather than diminished. Every new observation added a fragment of truth, but the whole remained elusive. The acceleration was measured, the shape inferred, the absence of a tail confirmed. But the questions only multiplied. Each answer became another doorway into the unknown. Philosophers of science noted that the discovery illustrated a profound truth. The universe is under no obligation to fit the categories humanity creates. Oumuamua was a reminder that nature often exceeds imagination, that the cosmos writes in languages not yet understood. The textbooks had been prepared for asteroids and comets, for icy bodies and rocky shards. But they had not been prepared for this. The scientific shock rippled beyond the laboratories and observatories. It reached into the imagination of the public, into the pages of novels, into debates on what it means to encounter something truly alien. It reminded humanity of its own vulnerability, of how little it knows about the interstellar environment through which the solar system drifts. If one fragment could pass so suddenly, how many others are out there unseen? What might the next bring? The questions lingered, haunting the silence left by the departing traveler. For in the end, Oumuamua was not only an object of study, it was a mirror held up to human knowledge, showing both how far science had come and how far it had yet to go. Even now, as it speeds away into the darkness, the data remains incomplete, the mystery unresolved. It accelerated without a tail. It tumbled without balance. It entered without warning and departed without return. It refused the names offered to it. In this refusal lay the true shock. Not that the object was strange, but that it revealed the strangeness of reality itself. The cosmos is not bound by human categories. It is vaster, more subtle, more unpredictable than the neat diagrams of textbooks can contain. Oumuamua was the proof, a fleeting visitor that left astonishment in its wake, a reminder that the universe is still capable of surprise. The scientific shock has not faded. It remains, echoing through every telescope that now scans the skies, waiting for the next messenger. For if there was one, there will be others. And with them will come new questions, new shocks, new reminders that in the silence of interstellar space, the universe still keeps secrets humanity has not yet learned to name. The window was brief. By the time astronomers realized what Oumuamua was, it was already leaving. The solar system had granted only a short glance, a fleeting chance to study this visitor before it slipped back into the dark. At its closest, the object was faint even in powerful telescopes, a point of light against a canvas already crowded with stars. Within weeks, it would dim beyond the reach of instruments on Earth. Time was the greatest enemy, and so began a race against the vanishing. Every telescope that could be turned toward Oumuamua was brought into service. The Pan-STARRS survey that first noticed it continued to track its fading light. Ground-based observatories across the world joined in, their domes pivoting night after night, hungry for data. The European Southern Observatory's Very Large Telescope, the Gemini Observatory and others captured its spectrum, chasing whispers in the starlight reflected from its surface, from orbit. The Hubble Space Telescope was called upon, its eyes sharp enough to follow objects invisible from the ground. Even the Spitzer Space Telescope, designed for the infrared, was directed toward it, hoping to detect heat signatures or faint emissions too subtle for visible light. The campaign stretched across continents and into space, humanity's instruments converging in a rare moment of unity, all focused on a single tumbling shard. The data was fragmentary, but it carried clues. Spectral analysis revealed a surface tinged with red, a hue familiar from many small bodies in the outer solar system. Cosmic rays, striking for millions of years, had weathered its skin, baking it into shades of crimson and brown. It was not pristine. It was ancient, scarred by eons of drifting through interstellar space. Yet even here, anomalies emerged. The reflectivity, or albedo, was low, darker than ice, dimmer than many asteroids. Its surface seemed to drink in sunlight, shining only faintly. If it were rich in volatile ices, as many comets are, none revealed themselves. No plume of gas or dust could be detected, not even by Spitzer's sensitive instruments. And yet its motion betrayed a push. Acceleration without exhaust, a comet without a coma. It was a paradox that resisted the ordinary language of astronomy. The object's rotation added to the strangeness. Careful measurements of its brightness revealed a rhythm, fluctuating as it turned. But the rhythm was not steady. Oumuamua was not spinning smoothly around a single axis. It was tumbling, rolling chaotically through space, its surfaces alternately flashing and fading as they caught the light. The amplitude of those fluctuations told a deeper story. The body was extreme in shape, elongated to proportions rarely seen. Some calculations suggested a ratio 10:1, a form stretched like a shard of glass or flattened like a coin. No consensus formed. Some models pictured it as a cigar, a spindle adrift between stars. Others imagined a pancake, thin and broad, wobbling as it spun. The data allowed both, but confirmed neither. It was a riddle drawn in shadow and light, geometry glimpsed only in silhouette. For astronomers, the challenge was cruel. Every answer carried uncertainty. Every measurement came with margins wide enough to keep doubt alive. The universe had offered a visitor, but not enough time to understand it. Observations were constrained to weeks when years were needed. By December of 2017, the object was already too dim for the largest telescopes to follow. The Hubble Space Telescope captured the final measurements before it vanished, a handful of data points fading into the noise of the sky. The questions outnumbered the certainties. Why did it accelerate without visible exhaust? Why was its shape so extreme? Why did it tumble so erratically? Why was there no tail, no halo of gas, no signature of a cometary heart? Each answer proposed by theory found itself undone by another observation. Some scientists argued the gases had escaped too diffusely to detect, forming jets too faint to be seen but strong enough to nudge the body outward. Others believed the acceleration was a clue to its structure, perhaps porous, perhaps fragile, a fractal of dust and void, pushed subtly by solar radiation itself. If thin enough, sunlight alone could provide the extra force. This in turn fed speculation that it might resemble a solar sail, natural or otherwise. But these were only models, mathematical sketches painted over the few data points available. The reality of Oumuamua remained beyond direct reach. No spacecraft had been nearby. No mission had been prepared to intercept it. It had entered unannounced, and the technology to pursue it did not exist. The frustration among astronomers was palpable. Here, at last, was the first confirmed interstellar object, the very thing theorists had predicted for decades. And yet the observations were so few, the time so short, that the mystery would remain unresolved. Even the instruments humanity had sent into space could not reveal all. Hubble saw a fading point. Spitzer detected nothing at all. It was as if the object had conspired with distance and time to guard its secrets. What was left was a collage of impressions. A red surface, a dark albedo, a tumbling spin, an elongated or flattened shape, an unexplained acceleration, and a trajectory that carried it beyond the solar system, never to return. In these fragments, humanity glimpsed something profound. Here was an object that had traveled for perhaps millions of years, across the gulfs between stars, carrying the scars of interstellar radiation. It was not part of this sun's story. It belonged to another, perhaps long gone, perhaps still burning in some distant cluster. It had wandered across the galaxy only to pass, for a fleeting moment, through the awareness of Earth. The deeper the investigation went, the deeper the uncertainty became. Each telescope added detail, but none erased the contradictions. Nature had presented a puzzle too complex for the brief time allowed. In this way, Oumuamua became a symbol not only of discovery, but of the limits of discovery. Even with the most advanced instruments, even with global cooperation, the universe could still reveal something and then conceal it again before comprehension could be achieved. The scientific community responded in the only way it could. Papers were written, models constructed, speculation offered, debated, discarded, revived. But the object itself moved on, silent, untouched by the efforts of those who watched it from afar. For philosophers of science, the episode raised haunting reflections. What is knowledge when the evidence is so fleeting? What is certainty when the subject vanishes before it can be fully studied? Oumuamua reminded humanity that it does not command the cosmos. It waits upon the timing of chance, upon windows that open and close without regard for readiness. In the end, the deeper investigation yielded no final truth. Instead, it yielded a paradox. The more was learned, the less was known. The object was cataloged, named, and tracked. Yet in the essential questions, what it was, how it formed, why it moved as it did, the answers dissolved into speculation. What endures is not clarity, but wonder. The telescopes that chased it across the sky did not resolve its nature, but they did reveal its strangeness, its refusal to conform, its resistance to being explained, and in that refusal lay the essence of the mystery. Oumuamua was a messenger not of knowledge, but of limits. It showed that even with the reach of modern astronomy, there are things that slip past, things that appear only briefly and then vanish, leaving behind not certainty, but awe. In this sense, the investigation was not a failure. It was a lesson written in light and absence, a reminder that the universe does not owe answers. The world's greatest telescopes had turned their gaze upon a single shard of interstellar space. They gathered what they could, and then the shard moved on, back into the silence from which it came. What remains are the questions, luminous in their own way, burning like faint stars in the imagination. For the brief time it was visible, Oumuamua forced humanity to look outward with urgency, to confront the vastness of interstellar space not as abstraction, but as reality. The investigation ended in darkness, but it also began something, a new awareness, a new readiness for what may come next. Because if one fragment has come, then there must be others. And perhaps the next will linger longer, offering answers instead of riddles. Until then, the memory of this first will remain. A red shard tumbling, accelerating, vanishing. A messenger seen but not understood. A question written across the sky. The deeper astronomers studied the path of Oumuamua, the stranger it became. The anomaly of its acceleration refused to vanish. Gravity alone could not explain it. The sun had pulled the object inward, but as it drifted back toward the dark, its speed did not match Newton's precise predictions. Something was giving it an extra push, subtle but undeniable. At first, the explanation seemed obvious. Comets accelerate when the sun's heat turns their ice to vapor, creating jets that act as natural thrusters. But telescopes saw nothing, no plume, no halo, no tail. Even the most sensitive instruments, including NASA's Spitzer Space Telescope, found no trace of gas or dust escaping into space. It was as though Oumuamua was being pushed by a hand that left no fingerprints. Some researchers proposed solar radiation pressure. Every object in space feels the faint but steady push of sunlight, photons imparting momentum as they strike its surface. But the force needed to explain Oumuamua's acceleration was greater than what a dense, rocky body could experience. For sunlight to move it in such a way, it would have to be thin, fragile, perhaps no thicker than a sheet of paper spread across hundreds of meters. It was not the description of a rock. It was the description of a sail. The speculation grew. Could Oumuamua have been something unlike any natural body observed before? A fragment stretched thin, a shard of ice or nitrogen from a distant exoplanet, eroded until only a delicate sheet remained. Or, more unsettling, could it be artificial? A relic of technology? Perhaps a derelict craft or a solar sail built to ride the starlight? Most astronomers resisted such leaps. Nature, they reminded, is vast and inventive. Exotic compositions could account for the anomaly without invoking intelligence. A hydrogen iceberg sublimating invisibly. A nitrogen shard chipped from a frozen exoplanet's surface. Each proposal sought to explain how something so fragile could survive the journey across interstellar space. But none of these answers sat comfortably. The hydrogen iceberg would not likely endure millions of years in the harsh radiation of the galaxy. The nitrogen shard required implausible numbers of Pluto-like worlds breaking apart in distant systems. Each theory bent probability, stretched imagination, and left a residue of doubt. The object's shape and spin only deepened the mystery. Its brightness shifted by factors of 10 as it tumbled, suggesting an extreme geometry. If it was cigar-like, it was longer than any asteroid ever seen. If it was pancake flat, it was thinner than any natural rock could plausibly remain without breaking apart. And its tumbling was chaotic, as though it had been struck or ejected violently, spinning end over end. Such fragility should have fractured under interstellar collisions, yet it had survived its journey intact. When compared with the catalog of solar system bodies, Oumuamua had no equal. Asteroids did not accelerate this way. Comets did not hide their tails. No moon fragment, no icy shard, no known phenomenon matched what the data revealed. In every category, Oumuamua was the outlier, the exception, the one that slipped beyond the rules. What unsettled the scientific world was not only the object itself, but the lack of agreement about even its basics. Was it cigar-shaped or flat like a disc? Was it ice, rock, or something more fragile? Was its acceleration driven by invisible gases or by the sunlight itself? Every group of astronomers produced a different answer. The data allowed no consensus, only competing interpretations. For the public, this uncertainty was fuel for fascination. When science could not agree, imagination rushed in to fill the silence. Headlines spoke of alien technology, Editorials speculated about probes from distant civilizations. Some pointed to the name Scout or Messenger, as if the universe itself had whispered its intent. The idea that Oumuamua might be more than stone or ice captured the human imagination with irresistible force. Harvard astronomer Avi Loeb's suggestion that it could be an artificial solar sail ignited controversy. Many scientists dismissed it as unlikely, pointing out that extraordinary claims require extraordinary evidence, and the evidence here was too thin. But the speculation could not be unspoken. For if Oumuamua had been built, even by a long-dead civilization, then humanity had just witnessed the passing of a relic older and stranger than itself. Not a natural shard, but a message written in matter. Even those who resisted the alien hypothesis admitted the discomfort of the unknown. Every natural explanation strained under improbability. The more scientists tried to fit it into familiar categories, the more it slipped away. The textbooks offered no comfort. Oumuamua refused their definitions, standing instead as a symbol of how much remains uncharted. By early 2018, the object was too distant to study further. It faded into the background of the stars, its light lost to noise. The telescopes turned away, not because the questions were answered, but because the visitor had gone too far to hear them. What remained was a trail of mystery, expanding even as the object itself receded. For astronomers, the shock turned into reflection. If one such object had crossed the solar system, then countless others must wander unseen. Perhaps they pass frequently, too faint to detect, their trajectories brushing silently through the outer regions. Oumuamua was only the first to be noticed, not the first to exist. The galaxy, they realized, must be seeded with wanderers, fragments of other stars' stories, carrying secrets of their origins. And yet the uniqueness of this first encounter could not be denied. It came without warning. It revealed itself in contradictions. It left without answers. It carried with it the possibility, however remote, that the universe had revealed not just its strangeness, but its intelligence. The escalation of the mystery did not end with its departure. Instead, it grew. In lecture halls, in conference papers, in whispered conversations between scientists, the same refrain echoed, "What was it?" Each possibility carried consequences profound enough to alter humanity's perception of its place in the cosmos. If natural, then the galaxy is richer and stranger than imagined. If artificial, then humanity is not alone. In either case, the lesson was the same. The universe is not finished with surprises. The familiar night sky, charted and mapped, still hides the extraordinary. Sometimes it reveals itself only briefly, in a shard that flashes past and leaves behind astonishment. Oumuamua's fading into the void did not close its story. It opened it. The mystery expanded as the object receded, its presence lingering in the collective imagination, its riddles haunting every telescope turned to the heavens since. It became less a discovery than a question, one that science could not yet answer and that philosophy could not ignore. For in the silence of interstellar space, one thing became clear. Sometimes the universe speaks not in words but in puzzles. Sometimes it answers not with clarity, but with mystery that deepens as it slips away. And Oumuamua was one such mystery, the first of its kind and perhaps not the last. When Oumuamua slipped into darkness, it left behind only numbers, light curves, trajectories, spectral hints, fragments of data that could not be woven into certainty. From these fragments, theories bloomed, natural and exotic, scientific and speculative. Each one an attempt to grasp the ungraspable, to pull meaning from a mystery already vanishing into the night. The first explanations clung to the familiar. If it accelerated like a comet, perhaps it was one despite its silence. Yet no gas, no dust, no tail betrayed its presence. So scientists sought to imagine forms of cometary matter, unlike those in the solar system. One theory proposed a hydrogen iceberg. Perhaps Oumuamua had been carved from the frozen clouds of a distant molecular nursery. In such places, hydrogen gathers in crystalline blocks colder than anything found near the sun. As it approached, the heat would sublimate the hydrogen directly into invisible gas, producing thrust with no visible trace. But calculations cast doubt. The galaxy is harsh. Cosmic rays would erode such fragile hydrogen long before the journey could be made. The iceberg would evaporate in the void, never surviving to reach this system. Another theory turned to nitrogen. Perhaps the shard was chipped from the surface of a distant exoplanet, a world like Pluto, locked in eternal frost. If struck by cosmic collisions, fragments of nitrogen ice could be ejected into space, wandering for eons. Such a shard, exposed to the sun, might sublimate quietly. Its gas is too faint to leave a visible tail. But for this to be likely, countless Pluto-like worlds across the galaxy would need to shatter and cast fragments outward in unthinkable numbers. The scenario was possible but improbable, demanding a galaxy more violent than models suggest. Other scientists envisioned it as the broken piece of a planetesimal, a building block of a planet from a star system not our own. Perhaps torn apart by tidal forces, perhaps shattered in a collision, it drifted for millions of years until chance delivered it here. Its elongated shape, its tumbling spin, its strange acceleration could be echoes of its violent origin, but this too left questions unanswered. Fragments of this kind, dense and rocky, should not accelerate without visible exhaust. The riddle endured. More exotic still was the proposal of fractal dust aggregates. Perhaps Oumuamua was not a solid shard, but a fragile lattice of dust, airy and porous like cosmic foam. Such a structure would be so light that radiation pressure alone could nudge it outward. But could such a delicate form survive the journey through interstellar space, battered by collisions, eroded by radiation? Many doubted it, though some argued the galaxy is filled with fragile things, drifting unnoticed until one brushes against the sun. Yet as natural theories strained, others turned to the extraordinary. Harvard astronomer Avi Loeb advanced the most controversial idea that Oumuamua was artificial. Not a rock, not a shard of ice, but a solar sail, a thin sheet designed to ride the pressure of starlight. The unexplained acceleration, he argued, fit this hypothesis. Its extreme shape and tumbling could be the remnants of technology long abandoned, drifting as wreckage or as probe. It might not be functional. It might not even be recent. It could be ancient, a relic cast adrift by a civilization gone long before Earth had formed. The idea spread quickly, igniting headlines and debate. Most astronomers resisted, pointing to the absence of direct evidence. They warned against reaching for the extraordinary when the ordinary, however unlikely, might still suffice. But the suggestion lingered. If nature had no ready answer, perhaps technology did. Perhaps the galaxy was not only filled with rocks and ice, but with artifacts, relics of minds that once dreamed beneath other stars. Between natural and artificial, the debate revealed more about humanity than about Oumuamua. For when data is scarce, imagination fills the void. To some, the hydrogen iceberg was comfort, a sign that nature still held surprises, but not intentions. To others, the solar sail was irresistible, a sign that humanity might not be alone. Each theory said as much about the thinker as about the object itself. In truth, the evidence allowed neither confirmation nor denial. There was no visible exhaust to prove cometary jets. There was no signature of metal or technology to prove construction. There was only the path, the acceleration, the shape inferred in shadows, the silence of a messenger already gone. And so the question deepened. Was Oumuamua an accident of cosmic mechanics or a deliberate artifact? A shard flung from chaos or a sail cast by design? The answer may never be known. The object is gone, too faint to follow, too far to catch. What remains is speculation, balanced between probability and possibility. But even speculation carries weight. It forces reflection on the limits of science, on the fragility of knowledge when windows of observation close too quickly. It challenges the assumption that all things must fit into categories already written in textbooks. It reminds humanity that the cosmos has always been stranger than expected. In conference halls and late-night discussions, astronomers acknowledged a humbling truth. For all the sophistication of modern instruments, for all the centuries of celestial study, a single object had arrived that defied understanding. Theories multiplied, but none prevailed. Oumuamua became less an answer than a mirror, reflecting back the hunger of human curiosity, the need to explain, the fear of the unexplained. Philosophers of science noted the deeper irony. Evidence, limited and fleeting, had created not clarity, but a widening gulf of imagination. Some saw in it the cold mechanics of probability, the natural outcome of collisions and chance. Others saw in it the faint outline of intention, the ghost of a message too vast to decode. Both views were anchored in the same fragment of light, the same vanishing curve across the sky. This is the paradox of Oumuamua. Its mystery is not only in what it was, but in what it left behind. It became a vessel for theories, a canvas upon which humanity painted its deepest questions. What is nature capable of? What might intelligence beyond Earth create? What does it mean that the universe still delivers riddles no one can solve? The object itself is gone, but its mystery grows, expanding in the absence of certainty. It forces science to confront its own boundaries and forces imagination to step beyond them. In this balance, between evidence and wonder, between probability and possibility, lies the enduring legacy of the first interstellar visitor. Oumuamua may never yield its truth, but in its passing it revealed something perhaps more profound. The cosmos is not silent. It speaks in fragments, in questions, and whispers carried across the void. And sometimes those whispers take the shape of a shard, tumbling, accelerating, vanishing, leaving only wonder in their wake. Oumuamua had come and gone too quickly. Its faint light had been captured only in fragments, its mystery locked away by distance and time. For many astronomers, the encounter was both a triumph and a frustration. It proved that interstellar visitors exist, but it also revealed how unprepared humanity had been to study one. The lesson was sharp. The next time a messenger drifts through, the world must be ready. In the years that followed, preparations began. On the horizon rose a new generation of observatories, armed not only with sharper eyes but with patience measured in decades. Foremost among them is the Vera C. Rubin Observatory in Chile. Its heart, the Legacy Survey of Space and Time, LSST, is designed to map the entire visible sky every few nights, gathering mountains of data with unmatched depth and cadence. Where pan-stars had glimpsed a fleeting point of light, Rubin will trace millions, cataloging faint wanderers that would otherwise pass unseen. It will not just detect interstellar objects. It will anticipate them, catching their approach earlier, leaving weeks or even months for observation. The pursuit of Oumuamua's successors is not hypothetical. In 2019, a second visitor arrived. This one bore a different name, Tuai Borisov, discovered by amateur astronomer Gennady Borisov through a telescope of his own making. Where Oumuamua had been silent and strange, Borisov was unmistakably a comet. Its coma glowed, its tail stretched across the void, its composition resembled the icy wanderers of the outer solar system. Here was the interstellar object the textbooks had expected. Ordinary in appearance, extraordinary in origin, the contrast was profound. With Borisov, astronomers could at last confirm what had long been theorized, that comets are indeed scattered across the galaxy, thrown out of their home systems to drift between the stars. Spectral analysis revealed carbon monoxide in abundance, more than most local comets, hinting at a birthplace colder than anything near this sun. It was alien, yet familiar. The kind of visitor that could be studied, classified, understood within the framework of known science. Side by side, Oumuamua and Borisov became twin lessons. One was the outlier, the object that refused categorization. The other, the exemplar, the proof that interstellar comets can and do exist. Together, they reframed the debate. If two had arrived within a few years, then countless more must wander unseen. The galaxy is alive with them. Fragments of other suns' stories, slipping between systems as silent witnesses of cosmic creation. This realization spurred more than theory. It drove plans for action. NASA and the European Space Agency began designing missions not to wait for discovery, but to chase it. Concepts emerged for interstellar interceptors, spacecraft built to lie in wait near Earth, ready to launch at a moment's notice when the next object appears. Equipped with fast propulsion and adaptive trajectories, they would not study from afar but pursue, photograph, sample, perhaps even touch. For the first time, humanity considered meeting a messenger not with distant eyes, but with direct presence. Such missions remain on drawing boards, but their urgency grows. Every interstellar visitor carries with it a unique record of its birthplace. Within its chemistry, within its structure, lie the signatures of other planetary systems. Systems never seen, worlds never touched. To intercept one is to reach across the gulf, to study not the distant light of exoplanets, but matter itself, delivered from beyond. Even as scientists planned, others listened. During Oumuamua's brief passage, SETI, the search for extraterrestrial intelligence, turned its instruments toward the object. Radio telescopes swept its location across many frequencies, seeking any artificial signal, any deliberate transmission. The result was silence. No beacon, no whisper of intent, but the act itself was historic. For the first time, humanity had listened to a body not born of this system, testing the possibility that it might not be a fragment of chance, but of design. The silence did not diminish the mystery. It only deepened it, leaving the question open for the future. The readiness of humanity has changed since 2017. The tools are sharper, the network stronger, the strategies clearer. The Rubin Observatory will soon sweep the sky with relentless rhythm. Other instruments will join it, from the James Webb Space Telescope to ground-based giants rising in Chile and Hawaii. Each one extends the reach of vision, making it less likely that another messenger will pass unnoticed. What has also changed is the mindset. No longer does astronomy see interstellar objects as rare curiosities. They are part of the cosmic landscape, as natural as comets and asteroids, as inevitable as the drifting of dust between stars. Each carries information older than Earth itself, pieces of alien chemistry traveling across the Milky Way. The next one will not arrive as a shock. It will arrive as an opportunity, and when it does, humanity will be watching. Perhaps the next will glow like Borisov, its tail a clear sign of ice. Perhaps it will be silent and strange, a second Oumuamua defying categories. Perhaps it will be something else entirely, a kind of object never imagined. Whatever it is, the telescopes will see it earlier, the data will be richer, and the chance to understand will be greater. The memory of the first visitor still lingers. Oumuamua came as a surprise, a riddle without an answer. Borisov came as confirmation, a comet written in familiar language. Together, they mark the beginning of a new era, the era of interstellar messengers. Not myths, not speculation, but objects that can be measured, studied, pursued. And yet even in readiness, the mystery remains. For what each visitor truly represents is not just a fragment of stone or ice, but a glimpse of the galaxy's vastness. They remind humanity that it is not isolated, that this solar system is one among countless others, each casting its fragments into the void. The Milky Way is a sea, and these objects are its driftwood, carried across gulfs of unimaginable time. One day, a spacecraft may fly beside such a fragment, photographing its surface, sampling its chemistry, decoding its origin. One day, data will replace speculation, but until then, the watch continues. Eyes turn to the night sky, instruments waiting for the next faint point of light that moves against the stars, the next messenger from elsewhere. Humanity now understands what is at stake. The first was missed in its fullness. The second confirmed the theory. The third and the fourth and those that follow may carry the answers that the first two left behind. This is the new frontier of astronomy. Not only the study of stars and planets, but of the wanderers that pass between them. Not only the search for distant worlds, but for the fragments of those worlds delivered here. Each one is both alien and familiar, both ordinary and extraordinary. Each one is a reminder that the galaxy is alive with motion, scattering pieces of its history across the void. The readiness grows. The tools sharpen. The waiting continues. And in the silence between discoveries, a truth endures. The next time, humanity will not simply watch as the messenger fades. The next time it will be waiting. When Oumuamua vanished into the black, it did not leave answers. It left questions, echoes, and reflections. It left a silence filled not with emptiness, but with wonder. For in that fleeting moment, humanity glimpsed a truth it had long suspected but never confirmed. The solar system is not sealed. It is not a closed world, isolated and alone. It is porous, open, vulnerable to fragments from elsewhere. Pieces of other suns, shards of alien histories, drift across the galaxy and on rare occasions cross paths with this fragile world. Oumuamua was one such fragment. Its orbit told the story clearly. It had not been born here. It did not belong to this family of planets and comets. It was the product of another star's chaos, another system's collisions, another history written far beyond the horizon of Earth. To witness it was to be reminded that the universe does not divide itself along the boundaries humanity imagines. The galaxy is not theirs and ours. It is one continuum of matter, restless and uncontained, forever scattering itself across the void. This realization carries humility. For all the power of modern science, for all the precision of mathematics and the reach of telescopes, the knowledge of Oumuamua rests on only a few weeks of data. A brief encounter, too short to resolve, too fleeting to capture in full. What remains are fragments, curves of light, shifting brightness, a trajectory traced across the sky. From these crumbs of information, generations may continue to speculate. A lifetime of imagination built upon a moment of observation. Here lies the paradox. Oumuamua is both known and unknown. It is the first confirmed interstellar object, identified, tracked, named. And yet it is also undefined, unclassified, ungrasped. It is a messenger defined by its mystery. It exists in the space between categories, forever refusing the labels humanity tries to place upon it. There is a lesson in this, a reminder that human knowledge is limited not only by the reach of its tools, but by the timing of chance. The cosmos offers glimpses, not guarantees. A visitor may appear unannounced, and if the instruments are not ready, its story will pass unrecorded. The universe does not wait. It does not repeat. It speaks in moments and then it moves on. And yet, in that brevity, something remarkable occurs. Even a fleeting shadow can ignite a fire of curiosity. Even a fragment glimpsed for weeks can inspire decades of wonder. Oumuamua proved that the human drive to question, to imagine, to seek meaning is as vast as the void itself. The object may have been silent, but it provoked voices in every corner of science, philosophy, and imagination. Its mystery became a mirror of the hunger that defines the human spirit. For what is science, if not the attempt to turn mystery into understanding? And what is philosophy, if not the reflection on mysteries that resist explanation? Oumuamua forced both into conversation. It became not just a subject of astronomy, but of human meaning. Was it accident or intention? Natural shard or relic of design? A comet in disguise or a sail abandoned to the stars? Each possibility spoke not only of the cosmos, but of humanity's place within it. If natural, it revealed the richness of the galaxy. the diversity of its fragments, the endless ways worlds can shatter and scatter across the void. If artificial, it whispered of others, minds that once looked outward, built vessels and cast them into the abyss. In either case, the message was profound. Humanity is not central. It is part of a larger flow, a participant in a cosmic drama that began long before Earth and will continue long after. There is humility in this, but also wonder. To know that this world is not isolated, but connected through invisible threads of drifting matter, is to feel both small and infinite. Small because Earth is one planet among billions, vulnerable to encounters beyond control. Infinite because every shard that drifts into the solar system brings with it the story of another star, another chapter of creation, another reminder that the universe is a single unfolding whole. Oumuamua may never yield its truth. Its secrets are locked in its tumbling form, carried now into interstellar night, far beyond the reach of telescopes. But perhaps the truth was never the point. Perhaps its gift was not knowledge, but perspective. It reminded humanity that certainty is rare, that mystery is abundant, and that the pursuit of meaning is as essential as the answers themselves. The cosmos is not empty. It is alive with motion, with fragments, with stories carried across unimaginable distances. Oumuamua was one such story. It passed briefly through the narrative of this solar system, then slipped away, leaving only questions in its wake. But those questions endure. They expand. They inspire. For in the end, the object was not just an interstellar visitor. It was a mirror. In that mirror, humanity saw its own hunger reflected. The hunger to know, to wonder, to place meaning against the vast backdrop of stars. It revealed how even in uncertainty, even in the absence of answers, the human spirit reaches outward, unwilling to let mystery pass without reflection. Oumuamua slipped away, but it left behind more than silence. It left behind an awakening. The next visitor will not be met with surprise, but with readiness. The instruments are sharper, the watch more vigilant. But even then, perhaps the greater legacy is not in preparation, but in perspective. The knowledge that humanity is part of a galaxy alive with wanderers, that fragments of other worlds drift through this one, that even in silence the universe speaks. And so the story closes where it began, with a question, not an answer. What does Oumuamua mean for humanity's place in the cosmos? Perhaps it means this, that meaning itself is the gift, that the object's true message was not written in data, but in wonder, that in chasing its mystery, humanity came face to face with its own reflection. A shard of elsewhere passed once through the sun's light. It tumbled, it accelerated, it vanished, but in the fleeting trail it left behind, humanity discovered not just a messenger from another star, but a mirror. And in that mirror it saw itself, fragile, curious, searching. Its hunger for meaning written, not on the stone of the object itself, but across the stars it came from, and the stars it returned to.